various interests. One of the interests are in the areas of the polyester geofabric strengthened masonry elements, brick masonry elements with geofabric joint reinforcement, fly ash based. He has a lot of research publications to his credit, and is in engineering mechanics and mechanics of materials. Okay, we would like to welcome Mr. Dr. SreeKeshava, sir, on board with us. Thank you, sir. So you can take it ahead from now, sir.
Thank you, madam. Sir, shall I start this session?
Thank you, sir.
Okay, madam. Okay, thank you. Yes, sir. Yes, sir. Thank you. Good evening, one and all present over here. So, my voice is audible, students. My voice is audible.
Yes,
sir.
Yes, sir.
Interact ಮಾಡ್ರಪ್ಪ ಎಲ್ಲ ಕನ್ನಡನ ಇಲ್ಲ ಕನ್ನಡ ಬರುತ್ತನ ಈಸಿಯಾಗಿ ಮಾತಾಡ್ತಿರಲ್ಲ interact ಮಾಡಿ. It's a very important subject. Okay, and also the main thing is if you crack structural engineering questions, more or less you are getting very good marks in your core paper. Okay, so that's why please you are already, the thing is within 1 month the exam will got over. That's why the time is very short. So I will try to give in the key points like what are the important things, all those how you have to remember, what are the important expected questions and all. ನಿಮ್ಗೆಲ್ಲ ಡೌಟ್ ಬಂದ್ರೆ ಇಮಿಡಿಯೇಟ್ಲಿ ಕೇಳಬೇಕು. ಗೊತ್ತಾಯ್ತನಪ್ಪ? Is clear? Shall we start?
Yes, sir.
Yes, sir.
Yes, okay, thank you. So see, myself, Dr. SreeKeshava KS, already the introduction is given by madam. So I am not much more wasting time by giving my introduction and all. So let me start this subject. The main thing is this is advanced structures. So the name itself indicates we are dealing with structural aspects, especially related to civil engineering structures. So in more or in your PWD syllabus, the thing is they are covered only analysis part. They are giving only analysis part. You are not having design. You are having only analysis. See, any one of you please interact with me. What is mean by analysis? What is mean by analysis? Any idea? It's meant by analysis in structures. See, you know that because you studied the thing in your 3rd semester to 7th semester, you are studying different material characteristics, and also you have studied regarding what is the behavior of the material under the influence of different types of loads. So the main thing is analysis deals with the determination of internal forces, what is happening inside the material with the response of external force. If you see any structure, they're subjected to different types of loading. It may be earthquake load, it may be dead load, or it may be live load. There are different kinds of loads, right? So when those loads are subjected, it's placed on structures, what happens? There is a mechanism takes place inside the structure. So that thing we cannot capture the things. It is invisible. But we are having different methods to find how much of reaction is developed because of the application of load, how much of resisting force developed in terms of stresses, what is the displacement in terms of strains. All those things we can determine using different methods. That is analysis. Analysis majorly helps to design the elements. What we are getting in analysis, it may be axial force, it may be shear force, it may be bending moment. Those are the things very helpful for design. What is meant by design? Design means proportioning the elements. What is the length of beam required? What is the depth of beam required? What is the length of column? What is the depth of column? What is the width of column? Any specific structure members needs to be dimensioned. How we are going to dimension? With the help of analysis results. So basically in advanced structures, we are going to deal with determining the resisting forces in terms of stresses, as well as slopes and deflections, and also the bending moments. So the main aspect of this particular subject is study the analysis part. Okay, so now we move on to the topic. the core topic is you are having two things. One is solid mechanics, that is your mechanics of materials or strength of materials. And another one is structural analysis, both SA1 as well as SA2, that is analysis of determinate structures as well as analysis of indeterminate structures. See, by looking into syllabus, they are mentioning directly the thing is two-dimensional stress system, that is principal stress, principal strain. The thing is clear, the two-dimensional stress system we are talking about. So the thing, one dimensional, we must know. So the questions you may expect in one dimension also from basics. So that's why what I'm doing, I will cover all the syllabi as well as I will try to cover what are the expected basic questions in these kinds of exams. Okay. Okay. If we start with this. Hello, sir. Creative Minds. Please allow me to share the screen. Yes, thank you.
Sorry.
Okay, okay, sir. Okay, thank you, sir. Thank you. Is this visible on the screen?
No, sir.
No. Now this is visible?
Yes, sir.
Yes, sir.
Okay, okay.
Yes, yes, yes. Visible.
Yes, thank you. So in simple stress and strain part, basically we are having these contents, that is important mechanical properties. We must know what are the important properties while we are dealing with mechanics of materials. We must know the things, because we all know that mainly the property of material will depends on several things. It may be its elasticity, its ductility, its brittleness. There are various very important properties are there. So the questions you may expect on these kinds of topics, and also stress and strain. What is mean by stress and what is mean by strain? How the importance is stress and strain in various members, and also stress strain curves. See, whatever I have developed the content, within this content you may expect 3 to 4 questions definitely without fail, because these are the basic aspects, and also deflection of different sections. So you are having different sections like circular, rectangular, tapered section. In tapered, you are having circular and rectangular with varying. One end is having diameter of D, other end it may be 2D, 3D. So it's a varying sections. Also, the very important thing is elastic constants. Whatever we going to study in Mohr circle or a two-dimensional stress system or a two-dimensional strain system, this elastic constants plays a major role. And also thermal stresses and strain. It's a simple topic and also very curious topic. Then lastly, principal stress and principal strain. Within this content, you may expect 3 to 4 very important question and very simple question. So my request is, please follow the things. If you are having any doubts, please feel free to ask immediately. Okay, I will clarify your doubts as well as the content. After the content, I will move on to MCQ questions. What are the expected MCQ? Or what are the types of various types of MCQ maybe appear in exam like that. Okay, so now we move on to the first thing, that's the important mechanical properties. So any one of you, please interact with me. What are the important properties? Do you know? See any 1 or 2 properties?
Elasticity.
Yes, elasticity. Very
Elasticity.
good. Yes. Others? Niranjan, very good.
Ductility.
Ductility. Yes, very important property.
Malleability.
Malleability is very important. Yes.
Toughness.
Toughness. Yes, very good. Toughness. Hardness. Yes. Others, please participate, because with the interaction only you are getting the accurate very high. Because if you do the discussion, definitely the question will if some question will appear in exam, unknowingly you will do the right answer. You will tick the right answer. That's why please participate in discussions. Others? Okay, let's see. The thing is, these are the very, very important properties: elasticity, plasticity, ductility, brittleness, malleability, toughness, hardness, strength, creep, fatigue, resilience. Let me discuss what is meant by elasticity. It's a simple definition. What is meant by elasticity? The elasticity means if you are loading a material, it will undergo deformation. If you do unloading, the deformation is recoverable. Yes, it will come to its original shape and its position. Then we term it as elasticity. Then what is meant by plasticity? What is meant by plasticity?
The body doesn't regain its original position after loading.
Yes, the body does not gain its original position after the removal of loading, which means it's under deformation state. So it's not having the ability to regain its original shape. That is a permanent setback, permanent deformation. That's we call it as plastic state. Then what is meant by ductility? Ductile. Is any idea what is meant by ductile?
The property of the material to deform into thin wire under the tensile force.
Yes, it's in just more or less a keen. That is, what you are telling is right. But I am asking, I am expecting the generalized definition, ductile. So it will allow long deformation. See, when you see the two types of material, there are two types of material generally, ductile material as well as brittle material. What happens in brittle material under the application of load?
Sudden fracture.
Broken down.
It will fail suddenly, right? But in the case of ductility, what happens? It will give different yielding patterns. It comes to plastic state, elastoplastic, rigid hardening state. So like that, the deformation is large. The deformation, well established deformation pattern is expected in ductile materials. Clear? Ductility means it's the resistance offered by the body to withstand long deformation. Clear? So that is called ductility. What is meant by brittleness?
Sir,
I've already explained.
just a minute. Sir, just a minute.
Yes.
If we are showing a PPT, it is not showing actually. That is what it is.
Please not showing.
No.
Oh.
So you have to. If you share the desktop itself so that it will.
Okay.
Unshare and share the complete desktop, so then you can see.
1 minute. Share screen or desktop full? Screen, right, sir?
Share screen.
Screen.
Now, yeah. Now it is visible.
Now it is visible.
Yes, sir.
Sir, please inform me because when I involving in teaching, I didn't really have a okay. Okay. Now it is visible. Is it visible?
Yes, sir.
Yes, please.
Thank you, sir.
Okay, thank you, sir. Okay.
Thank you.
So the important mechanical properties are elasticity, plasticity. What we discussed, elasticity we already discussed. We discussed plasticity. We discussed ductility. We discussed brittleness. See, one important question they will ask regarding properties. By confusing the statement type of question will appear, part A, part B. So you have to match with proper sentence with proper properties. That's very, very important. Okay. Now, what is malleability? I think already someone explained. What is meant by malleability?
Material can be.
Yes. If the material, if we mold to any shape, it's a malleable one. Which means if you apply compressive force, what happens? It expands. Yes?
Yes.
Okay. So here, malleability. It's a very, very important property of material. Malleable. What is my toughness? Toughness is just like it's a very, very important inherent property of material, which means if you see the stress strain curve diagram, generally I will generalize stress strain for mild steel. I will try to capture what happens. If you see, this is the fracture. So if you talk about the toughness, the area under which up to fracture, say energy dissipation, right? When we are loading happens, these are the energy dissipated under loading condition up to fracture. So whatever the area up to the strain energy stored up to the fracture is the resistance offered to the load. This is the load. Whatever the resistance is offering in terms of energy up to fracture is called toughness. There are two things. One is toughness, and another one is toughness, and another one is resilience. Resilience. Both are interrelated. Toughness and resilience both are interrelated. Why? Because when we are talk about toughness up to fracture, we are considering the energy. But if you come to resilience, what happens? This is an elastic point. Up to elastic point only, we are going to capture. Up to elastic point only, we are going to capture in resilience. In resilience. Yes. What is meant by hardness? What is meant by hardness?
The property of
Hardness
material to
means if
resist
you
the
take two
abrasion.
materials. If you take two materials, one material is stronger than other material. What it will do if you hit one by one? What happens? The strong material will make an impression on softer one. It's just like an impression. It's not a permanent one. So it make a you've done in BMT lab several experiments in hardness by using diamond shape indenter, right? Ball shape steel indenter. So it's just like an impression. It's just like an impression. Okay. So it's not. It's just like an impression. One is harder. One harder material will make a easy impression on softer one. Okay. Next, strength. What is meant by strength? Strength. Strength. It's a common thing. The strength of materials. What is meant by strength?
Property of material to withstand the load.
Yes, that is the it's the ability to withstand the load. How much? It may be in which, see, the strength is a general term. It's the ability of the material, how much it can withstand the load. But we are having different types of strength. How we are classified? Type of loading. If you are applying tensile force, what happens? You are getting tensile strength. If you are applying compressive force, what happens? You are getting compressive strength. If you are applying shear force, you are getting shear strength. If you are applying bending, that is flexure, perpendicular to the surface, then you are getting flexural strength. Very simple. Strength is a common word. It's a resistance to load. It's the ability, how much it will going to withstand. It depends on different types of forces. Depends on type of force, I can classify different types of strengths. What is meant by creep? It's very, very important property. Especially in concrete, we can expect creep. What is meant by creep? It's also a deformation, long term. In concrete bitbidri tumba dina dead load ade onde tara load biddu small deformation agi accumulate agi creep. It will tends to creep. Dead load is the main force is responsible for creep. Sometimes you may MCQ, it may appear creep. What is meant by creep? Is defined as creep is due to dead load plus live load, only dead load plus lateral load. These are the expected one. So the creep is because of the dead load. It's a very, very important thing. So, and also fatigue. What is meant by fatigue? See, say fatigue is a thing. It's also the resistance offered by the body under cyclic load. If you see the earthquake or wind blames, it's in the pattern of cyclic thing. So on that time we call it as fatigue. Clear? Any doubts in properties of materials? Any doubts?
Sir, notes ana provide ಮಾಡ್ತೀರಾ?
Class agli ಆಮೇಲೆ ಮಾತಾಡೋಣ. Any doubts? Clear? Shall we move on to next one? Stress and strain. Yes, what is meant by stress? Any idea? It's a simple thing. General definition.
It's force by area.
Yes, it's a general, you can easily say the force per area. Only that much is required. It's enough. Okay, no problem. So stress is generally, it's a force per area. Force unit is Newton. Area is mm square. So Newton per mm square. Generally, it's expressed as Newton per mm square, or 1 Newton per mm square is equal to MPa, megapascal. Clear? And general definition is stress is the resistance offered by the deformation. Okay. So, and also we are having two types of stresses. That is general, not types. It is not a type. General terminology. Nominal or engineering stress, actual and true stress. Can you define what is the difference between nominal and actual stress? Any idea?
No.
What is the difference between engineering stress and true stress?
Engineering stress is not real.
Okay.
It is,
Okay, I will explain. The thing is, ನಿಮ್ಗೆ mild steel specimen experiment ಮಾಡಿದಾರಲ್ಲ strength of materials ಅಲ್ಲಿ. So ಅವಾಗ ನಿಮ್ಗೆ ಏನಾಯ್ತು ಅಂದ್ರೆ ನೀವು ಒಂದು ಆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಸ್ಪೆಸಿಮನ್ ಅನ್ನ subjected to load versus stress versus strain, that is stress versus strain graph ನ ಮಾಡಿದಾಗ stress versus strain sigma versus e graph ಮಾಡಿದಾಗ so initially ಏನಾಯ್ತು ನಿಮ್ಗೆ it may be a linear one because it's having elastic behavior. Afterwards what happens, deformation, and afterwards the deformation will take place, so the material will gradually deforms and it fades. So what happens when the material will gradually deforms and it fades, it is the engineering stress strain graph. Whatever I am drawing, that is the engineering stress strain graph. So these kind of graphs you are expected in your laboratory. ನೀವು laboratory ನಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀರಾ ಅವಾಗ ಈ ತರ ಗ್ರಾಫ್ ಬರ್ತದೆ. But actually what is mean by true stress strain means, if you are taking, see how you are arrived at this thing, you are arrived at this thing by using the stress equal load by area and strain equals change in length by original length. When you are considering load by area for engineering stress strain curve, what happens, see when the specimen after few loading stage, it will take a failure pattern like this. There is a cone and cup arrangement, the area is reduced, right? After a few loading cycle, what happens, the area of specimen will get reduced. That's why these kind of pattern of stress strain are expected. But if you take whatever the actual area of the specimen, it may go some up, then it fades. So this is the true stress. In true stress, the only thing is you are considering original area of the specimen for stress computation P by A. For engineering stress, it's a laboratory one. Laboratory, the thing is clear, the area, whatever the necking will take place, the area will get reduced. So that's why this is the difference between engineering stress as well as true stress. Next one, strain. What is mean by strain? Strain is general definition, change in length by original length. This is the deformation per unit length in the direction of the deformation produced by the body. See, this is the engineering stress strain graph. It's very, very important. So this is the engineering stress strain curve. Please be aware. This is the engineering stress strain curve. This is the curve you are expected in your laboratory. See, there are different points, salient features. So you may expect some of the thing like stage 1. What is stage 1? Stage 1 is proportional region, that is Hooke's law is valid, that is elastic region. Then what happens, elastoplastic region. See, this is up to here, O to A, this is elastic one. Then elastoplastic yield point. After few yield point, this is strain hardening. Say in this phase, the material is getting permanent deformation, like it's trying to come its original shape, but it's not having the ability. Afterwards, what happened? It get fade. So here you are getting yield one. Afterwards, you are getting lastly you are getting fracture. So the main thing is upper yield point. It's very, very important. At C, you are having upper yield point. See, this is the upper yield point. This one is very, very important. Upper yield. Next, strain hardening stats. This is the part where the material is getting plasticity, that is permanent deformation. Ultimately, this is the maximum stress point. So this is the maximum stress point. So this is very, very important curve. And also types of tension failure. See, this is a simple thing you may expect in examination. Like if ductile material like mild steel is subjected to tensile force, which type of fracture you may expect? The fracture plane will be definitely cup and cone fracture, and the angle is 45 degrees. Similarly, if the brittle material subjected to same tension like your concrete or wood subjected to tensile force, it will break at exactly perpendicular, that's 90 degrees. This is very, very important angle. That's a fracture. Okay. Next, similarly, compression. If the material subjected to tension means ductile will get 45 degrees and brittle will get 90 degrees. But if you see the curious factor in ductile, what happens when the ductile material subjected to compression, it's just like a bulging. bulges. The material will become bulges. There is no clear failure pattern for ductile one. But if you see the compression for brittle one, the concrete specimen, your cube or cylinder subjected to load, once again the failure plane occurs at 45 degree. Once again the failure plane occurs at 45 degree. It's a very, very important point. You just take a note, because sometimes you may get what is the angle of inclination under tension for ductile. What is the angle? See, the angle for ductile and brittle is same under, that is tension and compression. You just observe 45 degree, 45 degree. But the thing is, the type of load plays a major role. This is because material property is placing significant effect. So this is very, very important thing. So for types of tension failures and types of compression failures. Next one, stress strain diagram. So it's very, very important thing. See the first one, it is representing for mild steel, high yield steel, high tension steel. The second one, see general question, rubber. See rubber, you just observe the stress strain graph for rubber. It's very, very less. Generally, what we will do in committed to mistake in examination, they will ask like which is having least Young's modulus of elasticity. We are thinking that rubber is having very good elastic one, because what we are thinking like rubber is very good elastic one. No, rubber is having least Young's modulus. Clear? See, and you see the concrete here, wood, and also aluminum, cast iron, mild steel. So these are some important stress strain graph for different materials. Behavior of various materials. See, this is a linear. See, this is very, very important one. So what is the graph indicates? Linear elastic. Stress versus strain graph. Clear? This is the linear elastic. Next one. See, elastoplastic. See, in linear elastic, only one line. In elastoplastic, this involve up to here elastic, then plastic. That's why this is elastoplastic. See this one, this is perfectly plastic. So perfectly plastic. There is no linear elastic one. So this graph is perfectly plastic. Perfectly plastic. Then you see, this is elastostate. Up to here, elasto. Next, this is a plastic strain hardening. This is the type of graph expected in strain hardening. Next, see these two, ideal rigid. These two curves generally you are seeing in fluid mechanics. Ideal rigid one, here x-axis, ideal fluid one. These two graphs is familiar in fluid mechanics. So generally you may expect question like which graph identify perfectly plastic, identify elastoplastic. They will give different graphs. So you have to identify the perfect graph. So this is very, very important. Stress strain curves for under different conditions, different various material conditions, material property conditions, linear elastic, elastoplastic, perfectly plastic, like that. You're having different conditions. See, deflection. What is mean by deflection or deformation? Any idea?
Upon a load, the material.
Yes. What is mean by deformation? Delta L. Please try, Marjorie.
Change in length.
Yes, change in length. Yes, obviously, if you are applying load, what happens? There's a change in length. So, because we are having various, this is an axial one type. This is axial elongation of prismatic bar. If the bar is prismatic, say prismatic member is subjected to this kind of loading. What is the deformation? See, generally we know that. What is sigma stress? What is stress?
Force by area.
Yeah, very good. What is strain?
Change in length by original length.
Very good. What is Young's modulus? What is the Hooke's law relationship between Young's modulus, stress, strain?
Stress is directly proportional to strain.
Yes, stress is directly proportional to strain. If you equate, you are getting stress equal E into E. You are getting E is the ratio of stress over strain, right? Now, if you substitute these two things, finally you are getting delta L equals PL by AE. This is very, very important. How you arrived this one. So it's very, very important thing. See, just whatever I have written with the reference of this, that is delta equal PL by AE. If you take delta, that is deformation PL by AE. And also if you take, this is very, very important. What happens? You know this equation, but this equation you are not familiar. Because this equation is slightly related to your structures. How? I'm talking about stiffness. What is mean by stiffness? Flexural stiffness. What is stiffness? EI by L. EI by L. Where you have studied this stiffness? You know moment area method, slope deflection method. They will be talking about in coming classes. That is stiffness. Okay, relative stiffness we are going to talk. See, that's be termed as K. K equal AE by L. See, when we are talking about area, AE by L, this is axial stiffness. EI by L, we are talking about Young's modulus, and I, moment of inertia, that is flexural stiffness, and EI is flexural rigidity. See, the same equation, if you replace by EA, you take this L to denominator, this L to here, shift it. So it will become EA by L or AE by L. What is AE by L? This is the axial stiffness. Therefore, P by K. Sometimes what happens, they will give axial stiffness value to evaluate deflection. ಅರ್ಥ ಆಗ್ತಿದೇನ್ರಪ್ಪ? ಕ್ವಶನ್ ಪೇಪರ್ ನಲ್ಲಿ ಆಕ್ಸಿಯಲ್ ಸ್ಟಿಫ್ನೆಸ್ ವ್ಯಾಲ್ಯೂ ಕೊಡ್ತಾರೆ. ನೀವು ಇದ್ಯಾವ್ದಿದು ಆಕ್ಸಿಯಲ್ ಸ್ಟಿಫ್ನೆಸ್ ಲೋಡ್ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾನೆ ಗೊತ್ತೇ ಇಲ್ಲ ಅನ್ನೋ ತರ ಫೀಲ್ ಮಾಡಬೇಡಿ. ಡೆಲ್ಟಾ ಈಕ್ವಲ್ ಪಿ ಬೈ ಕೆ ಡೈರೆಕ್ಟ್. ಹೌ ಯು ಅರೈವ್ಡ್? ವಿ ನೋ ದಟ್ ಡೆಲ್ಟಾ ಈಕ್ವಲ್ ಪಿ ಎಲ್ ಬೈ ಎಇ. So P divided by AE by L. AE by L is nothing but K. That is the stiffness. That is the stiffness of member. Clear? This is very, very important one. Next, due to self weight, W delta equal WAL by 2AE. Sometimes they will give density. Density is nothing but gamma. Gamma is represented by when that is the thing is, if the bar is like this, it will subject it to W self weight. So on that cases, how this is the density, how we are relating it. Gamma is nothing but, if you observe this, we are getting like this W gamma, see W L by 2AE is very, very important. Sometimes what happens, they will mention gamma L square by 2E. How? Because this A will get cancels and W, so that is gamma, where gamma equals A, where gamma equals by E get 2A E, whatever the gamma we are replacing by L square. Why L square? This is L. We are going to just L by AE. So L into L will get gamma. We just replacing W and L square. L into L square, and A will get cancels. So finally, this is the thing. Sometimes you may expect the problematic part, and also circular. So these are the things you just remember directly the equation. Don't go with derivations and all. So because generally they will ask direct derivation. They will give 4 choices. What is the circular tapered section? 4PL pi E D1 D2. See, don't think like that. They will ask in-depth problem regarding these things, because you know that this is like KPSC is conducting this particular exam. So they are more or less, they will mainly focusing on basics. So well, the thing is, the derivation is very large. Don't go with all derivations and numericals. You just the thing is, you just glance the derivation. Sometimes in MCQ they will ask direct derivation of final whatever the deflection due to rectangular tapered bar. So on that case, you just take the whatever the proper answer. So now this is very, very important concept. Well, before going to this concept, I will take MCQ part of for this for this content. I will take some MCQ part. So please try to answer those MCQs. Then you are getting idea. Is my screen is visible? Kanasta ideyappa?
Yes, sir.
Okay, shall we start MCQ for up to this part? So elastic constants, because 1 hour class, if I take elastic constants, it will become only theoretical things. So I am not, because the examination pattern is MCQ, we must focus on very, very important aspects, MCQ. The thing is, whatever I explained, the content, that's enough. If you learn that much, is enough. So we will solve more and more MCQ. We are getting perfection. Clear? Shall we start MCQ?
Yes, sir.
Okay. See, match the mechanical properties. Select the correct answers using codes. See, what is list one? What is list one? List one is mechanical properties, right? Kanasta idea?
Yes, sir.
Sir.
Yes, creep,
Yes, sir.
ductility, tenacity, brittleness. See, this is a list two. Yes, now tell me, what is mean by creep? By looking the list two. Please, guesses. Any guesses?
It's 2, sir. Option 2.
Option 2. Others? For one, for A, option 2, creep. Okay, next. What is the definition of ductility? Okay, I will give you the codes. Yes, please guess. A, B, C, D. Which one is right?
D, sir.
Is B? B? And the others? Yes, see, creep. What is mean by creep? What is mean by creep? Creep is the deform under sustained loading. If you see dead load, what is dead load? Dead load is which kind of load? Dead load is sustained, which means it is a fixed load. This whatever the member, dead load, this is not varying one. This is fixed, sustained loading. It's in the place. It's constantly applying one. So next.
Sir, dead load ಅಂದ್ರೆ sustained load ಅಂತ sir.
Yes, under time ನೋಡು ಡ್ಯೂರೇಷನ್ ಅಲ್ಲಿ ಈಗ ನಿಂಗೆ 1 ವರ್ಷ ಬೀಮ್ ವೆಯ್ಟ್ ಹಂಗೆ ಬೀಳ್ತಾ ಇರ್ತ ಅದ್ರ ಮೇಲೆ ಅದ್ರದ್ದು ಸೆಲ್ಫ್ ವೆಯ್ಟ್ ಮಾತ್ರ ನೋಡು, ಅದ್ರ ಮೇಲೆ ಆಗ ಲೈವ್ ಲೋಡ್ ಎಲ್ಲ ನೋಡ್ಬೇಡ. ಕ್ರೀಪ್ ಡೆಫಿನೇಷನ್ ಗೆ ಮ್ಯಾಚ್ ಆಗ್ತದ ಅಷ್ಟು ಗೊತ್ತಾಯ್ತಾ? What is meant by tenacity? Tenacity is the name itself. Tenacity means tensile, ultimate tensile strength. This is the B1. Next, ductility. This is the ability to go through changes of shape without rupture. This is very, very important. It will not going to rupture, but it will change the shape, the ability. So next, brittleness. See, without knowingly, the material will get failed suddenly, right? It's a thing. It's a very, very important thing. The thing is, you have to think. They may ask, ಇದನ್ನೇ ಕೇಳಬೇಕು ಅಂತ ಇಲ್ಲ. ದೇ ಮೇ ಆಸ್ಕ್ ಲೈಕ್ ಬೇರೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಪ್ರಾಪರ್ಟಿ ಯಾವ್ದು ಹಾಕ್ಬೋದು, ಸಡನ್ ಆಗಿ ಬಂದ್ಬಿಟ್ಟು ಅವ್ರು ನಿಮ್ಗೆ ಎಲಾಸ್ಟಿಸಿಟಿ, ಪ್ಲಾಸ್ಟಿಸಿಟಿ, ಎಲಾಸ್ಟಿಕ್ ಹಾರ್ಡನಿಂಗ್ ಯಾರನ್ನ ಕೇಳ್ಬೋದು, ಗೊತ್ತಾಯ್ತಾ? ನಾವು ಇನ್ಎಲಾಸ್ಟಿಕ್, ದಿಸ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ಮಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ. ಅಂದ್ರೆ ನಿಮ್ಗೆ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಮಟೀರಿಯಲ್ ಹೇಳಿದ್ನಲ್ಲ, ಸ್ಟ್ರೆಸ್ ಸ್ಟ್ರೈನ್ ಗ್ರಾಫ್ ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿ ಅದ್ರ ರಿಲೇಟೆಡ್. ನೌ ಪ್ಲೀಸ್ ಗೆಸ್, ವಾಟ್ ಈಸ್ ಮೀನ್ ಬೈ ಇನ್ಎಲಾಸ್ಟಿಕ್ ಮಟೀರಿಯಲ್? What is mean by inelastic material? Inelastic, name itself indicate
Large plastic zone.
Number?
Large plastic zone.
Large plastic zone, inelastic material. Next, any other guesses? ನಿಮ್ಗೆ ಗೊತ್ತಿರೋ ಗೆಸ್ ಮಾಡಿ. ಓಕೆ, ನೀವು ಈ ತರನ ಹೇಗೆ ಟ್ಯಾಕಲ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಮೊದಲನೇ ನೋಡ್ಬಿಟ್ಟು ಹುಡುಕ್ತಾ ಕೂತ್ಕೋಬಾರ್ದು. ನಿಮ್ಗೆ 4 ಕೊಟ್ಟಿದ್ದೀನಲ್ಲ, 4 ಆಪ್ಷನ್ ಐತಲ್ಲ, ಯಾವ್ದು ಬರುತ್ತೆ? ಬ್ರಿಟಲ್ ಬರುತ್ತಾ? ಬ್ರಿಟಲ್ ಅಂದ್ರೆ ಏನು ನಿಮ್ಗೆ ಗೊತ್ತು? ಬ್ರಿಟಲ್ ಅಂದ್ರೆ ಏನಪ್ಪಾ? ಬ್ರಿಟಲ್ ಅಂದ್ರೆ ಸಡನ್ ಫೇಲ್ಯೂರ್ ಆಗೋದು ಅಲ್ವಾ? ಅಂದ್ರೆ ಏನ್ ಬರ್ಬೋದು ಅದಕ್ಕೆ? ಸ್ಟ್ರೈನ್ ಈಸ್ ನಾಟ್ ರಿಕವರ್ಡ್ ಆಫ್ಟರ್ ಲೋಡಿಂಗ್. ಯಾವ್ದಕ್ ಬರ್ಬೋದು? ಸ್ಟ್ರೈನ್ ರಿಕವರ್ ಆಗತ್ತಾ ಇಲ್ಲ. ಸ್ಟ್ರೈನ್ ರಿಕವರ್ ಆಗಲ್ಲ ಅಂದ್ರೆ ಏನರ್ಥ? ಆಮೇಲೆ ಇನ್ನೊಂದು ಏನ್ ಕೇಳಿದ್ರೆ, ನೀವು ಒಂದು ಲಿಸ್ಟ್ 1 ನೋಡಿ, ಲಿಸ್ಟ್ 2 ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಮ್ಯಾಚ್ ಮಾಡಿ, ಇಲ್ಲ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಮಟೀರಿಯಲ್ ಮ್ಯಾಚ್ ಮಾಡಿ. ಅದು ನೀವು ಮೊದಲಿಂದ ನೋಡ್ತಾ ಕೂತ್ಕೋಬೇಡ್ರಿ. ಯು ಡೋಂಟ್ ಸಿ ದ ಥಿಂಗ್ ಇಸ್ ಲಿಸ್ಟ್ 1, ಲಿಸ್ಟ್ 2. ಬೈ ಲುಕಿಂಗ್ ಲಿಸ್ಟ್ 1, ಡೋಂಟ್ ಗೋ ಫಾರ್ ಲಿಸ್ಟ್ 2. You just see the characteristics, then identify the material. It's very good, right? Yes, please tell me the code. Which one is correct? Which one is correct? Answers, please. Try to give answers. Niranjan, Chidanand, Shivu.
Yes, sir.
Yes, please try to give answer, man. ಟ್ರೈ ಮಾಡ್ಬೇಕು. ನೀವು ಟ್ರೈ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಇನ್ನಷ್ಟು ಇದನ್ನ ಒಂಥರ ಐಡಿಯಾ ಬರ್ಬೇಕು ನಿಮ್ಗೆ. ಮಾಡಿ 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 ತಪ್ಪಾಗತ್ರಿ, ಮಾಡ್ರಿ. ಇಲ್ಲಿ ತಪ್ಪು ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಸರಿ ಮಾಡ್ತೀರಾ.
Option C.
Option C. Option C. Yes, others.
Option-
You see the option C.
Sir, B, sir. Option B.
Inelastic
Option
material.
B, sir.
Option
B, sir.
B.
B.
Option B, sir.
Okay, how many of you option B? So many option B. So many are telling option B. Others, any other some special answers? See, first thing, option C ತಗೊಳ್ಳೋಣ. First option C ಹೇಳಿದ್ರಲ್ಲ, just ನಿಮ್ಗೆ ಕ್ಲಾರಿಫೈ ಮಾಡ್ತೀನಿ. Option C ಬಂದ್ರೆ first one 4 inelastic material ಗೆ strain is 0 up to a stress level and then stress remains constant. See, inelastic and takshana it's not having elastic property. There is no matter. The thing is zero stress. So like chances. The thing is very irade illa. So adana ಇನ್ನು ನೀವು ಎರಡನೇದಕ್ಕೆ ಮೂರನೇದು ಹೇಳಿದಾಗ ರಿಜಿಡ್ ಪ್ಲಾಸ್ಟಿಕ್ ಅಂತ ಬಂದ್ರೆ ರಿಜಿಡ್ ಪ್ಲಾಸ್ಟಿಕ್ there are two terms, rigid plastic. So strain is not recovered after loading, right? Strain is not recovered after loading. ಇದ್ರಲ್ಲೂ ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಆಯ್ತು, ಹಿಂದೆ ಮುಂದೆ ಮಾಡಿದೀರಾ. But if you see the 2 and 1, that is ductile material, large plastic zone. Obviously, right? I have explained. Ductile means it's a large deformation zone. ಸರಿ ಇದೆಯಾ? ಸೊ ನಿಮ್ಗೆ ಫಸ್ಟ್ ಎರಡು ಕನ್ಫ್ಯೂಷನ್ ಆದ್ರೂ ಯು ಪಿಕ್ಡ್ ಫಾರ್ ದಿಸ್ ಒನ್. ದಿಸ್ ಇಸ್ ರೈಟ್. ಇದ್ರಲ್ಲಿ ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ಎನಿ ಡೌಟ್ಸ್? ನೋ
sir.
Brittle material, if the ductile material is large plastic zone, in brittle material, have you observed the stress strain graph? ನಿಮಗೆ ತೋರಿಸಿದ್ನಲ್ಲ, ಅದ್ರಲ್ಲಿ ಏನಾದ್ರು ನಿಮ್ಗೆ ಪ್ಲಾಸ್ಟಿಕ್ ಝೋನ್ ಇತ್ತ ಬ್ರಿಟಲ್ ಮೆಟೀರಿಯಲ್ ಅಲ್ಲಿ?
ಇಲ್ಲ ಸರ್.
ಇಲ್ಲ. ಸೊ ಯು ಐಡೆಂಟಿಫೈಡ್ ದೀಸ್ ಟು ಥಿಂಗ್ಸ್ ಈಸಿಲಿ. ನಾವು ಸರ್ಚ್ ಯಾವ್ಯಾವ್ದು ಎಲಿಮಿನೇಟ್ ಆಯ್ತು?
B and D
ಎಲಿಮಿನೇಟ್ ಆಯ್ತು. ಉಳಿದಿರೋದು ಯಾವ್ದು? A and C. ಯಾವ್ದು ಇವಾಗ ಹೇಳಿ? ಏನಾ ಸಿ?
A, sir.
ಏನಾ ಪಕ್ಕ?
Yes, sir.
ಸಿ. ಇದಕ್ಕೆ ಹೇಳಿದ್ದು A is right answer. Why A is right answer? Inelastic material means strain is not recovered after unloading. See, ಎಷ್ಟು ಸಿಂಪಲ್ ಆಗಿದೆ. strain is not recovered after unloading in inelastic. See, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ elastic state. ಈಗ ಗ್ರಾಫಿಂಗ್ ತಗೊಂಡ್ರೆ ನೀವು ಅಪ್ ಟು ಹಿಯರ್ ಇಸ್ elastic state. ನಿಮ್ಗೆ ಈ ತರ ಗ್ರಾಫ್ ಮೂವ್ ಆದ್ರೆ, ಸೊ ದಿಸ್ ವಾಟ್ ಎವರ್ ದಿಸ್ ಸ್ಟೇಟ್, ದಿಸ್ ಇಸ್ ನಾಟ್ ಎಲಾಸ್ಟಿಕ್ ಒನ್. ಎಲಾಸ್ಟಿಕ್ ಅಲ್ಲ ಅದು. ಎಲಾಸ್ಟಿಕ್ ಅಲ್ಲ ಅಂದ್ರೆ ಇನ್ಎಲಾಸ್ಟಿಕ್ ಮೆಟೀರಿಯಲ್ ಏನಾಗುತ್ತೆ? ಸ್ಟ್ರೈನ್ ಇಸ್ ನಾಟ್ ರಿಕವರ್ಡ್ ಆಫ್ಟರ್ ಅನ್ಲೋಡಿಂಗ್. ವೆರಿ ಸಿಂಪಲ್. ಕ್ಲಿಯರ್? ಎನಿ ಡೌಟ್ಸ್? ಸೊ ಎ ಇಸ್ ದಿ ರೈಟ್ ಆನ್ಸರ್. ಸಿ, ನೀವು ಥಿಂಕ್ ಮಾಡ್ಬೇಕು ಯಾವ್ದು ಪ್ರಾಪರ್ಟಿ ಯಾವ್ದಕ್ ಬರುತ್ತೆ. 2 3 ನಿಮ್ಗೆ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. ಎರಡು ಗೊತ್ತಾಗುತ್ತೆ. ಕೆಲವು ಟೈಮ್ ಏನಾಗುತ್ತೆ, ನಿಮ್ಗೆ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಒಂದೇ ಒಂದ್ ಸರಿ ಇರುತ್ತೆ, ಅದ್ ನಿಮಗ್ ಶ್ಯೂರ್ ಇರುತ್ತೆ. ಗೊತ್ತಾಯ್ತಾ? ಸೊ ಅವಾಗ ನೀವು ಈಸಿಲಿ ಮಾರ್ಕ್ ಮಾಡ್ಬೋದು. ನೀವು ಮುಂಚೆಯಿಂದ ನೋಡ್ತಾ ಕುತ್ಕೊಳ್ಬೇಡ್ರಿ. ಈ ತರ ಮ್ಯಾಚ್ ದಿ ಫಾಲೋಯಿಂಗು ನಿಮ್ಮ ಟೆಕ್ನಿಕಲ್ ಪೇಪರ್ ನಂಗೆ 2 3 ಇರ್ತದೆ, 3 2 ಇದ್ದೇ ಇರ್ತದೆ. ಸೊ ಆ ತರ ಮ್ಯಾಚ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಅಲ್ಲಿ ಮಾತ್ರ ಮಾರ್ಕ್ಸ್ ನ ಮಿಸ್ ಮಾಡಬಾರ್ದು. ವಾಟ್ ಎವರ್ ಇಸ್ ದ ಸಬ್ಜೆಕ್ಟ್, ನೀವೆಂತ ಮಾಡ್ಬೇಕು, ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಲಿಸ್ಟ್ ನಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದಾರು ನಿಮ್ಗೆ ಗೊತ್ತಿರುತ್ತ್ರಿ. ನೀವು ಓದ್ತಾ ಇದ್ದೀರಾ, ನೀವು ಇಲ್ಲಿ ಬಂದು ಕಲಿತೀರಾ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಒಂದಾರು ಗೊತ್ತಿರುತ್ತೆ. 1 2 ಐಡೆಂಟಿಫೈ ಮಾಡಿ, ಬೆನಿಫಿಟ್ ಆಫ್ ಡೌಟ್ ಅದನ್ನ ನೆಕ್ಸ್ಟ್ ರೌಂಡ್ ನೋಡ್ಬೇಕು. ಗೊತ್ತಾಯ್ತಾ? ಸೊ ಎನಿ ಡೌಟ್ಸ್? ಶಾಲ್ ಐ ಮೂವ್ ಆನ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್? ನೀವು ಓಕೆ ಅನ್ಬೇಕು, ಇಲ್ಲ ಅಂದ್ರೆ ನೀವು ನನ್ನ ಕೇಳಬೇಕು. ಶಿವು, ಸಾಗರ್, ಸಿ ಇದೀರಪ್ಪ, ಎಲ್ಲ ಇದೀರ ತಾನೆ? ಓಕೆನಾ? ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
Very good. See, once again I have given the match the following. See, here I have given various test stages. This is the test. There is a laboratory point of view. I have set this particular thing. Like you've done that is experiment. Might steel subjected to some and so loading, tensile loading. But the first stage, what happens? Second stage, what happens? I have shown the stress strain graph of engineering stress strain graph for might steel. So for that particular graph, this question is related. Now tell me the answer. What is the first stage?
A, sir.
What is the first stage in list option?
Limit of proportionality.
First stage, limit of
Limit of
proportionality. Next,
proportional.
second stage,
Yield
see,
point.
you take a graph. So limit of proportionality. Next,
Yield
of-
point.
yield
Yield
point.
point.
Next, what is next?
Ultimate stress.
This is ultimate. Next,
Breaking stress.
Breaking.
breaking. 1, 2, 3, 4. So which option is right?
A, sir.
A. One
B.
is limit of proportionality. The B is one, that is next after the limit of proportionality, yield will occur. Next, that is ultimate stress will occur. Next, breaking stress will occur. So 1, 2, 3, 4. That is 2, 1, 4, 3. 2, 1, 4, 3. Yes, right. See, don't do it in hurry. ಅಯ್ಯೋ ನಾನು ಅರ್ಧ ನಿಮಿಷಕ್ಕೆ ಮಾಡ್ಬಿಡ್ಬೇಕು ಹಂಗೆಲ್ಲ ಇಟ್ಕೋಬೇಡ್ರಿ. See, the thing is clear. If you are attempting for 100 question, 200 marks, if you are having shoe short of 50 questions, fine, you are through. So don't make it a hurry. ನಾನು ಎಲ್ಲ ಮಾಡ್ಬಿಡ್ಬೇಕು ಎಲ್ಲ ಆಗ್ಬಿಡ್ಬೇಕು ಅಲ್ಲ, ನೀವು ಬರೋದನ್ನ 100% ಮಾಡ್ಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಕ್ರಾಸ್ ವೆರಿಫೈ ಮಾಡ್ಕೊಂಡು ಕರೆಕ್ಟ್ ಆಗಿ ಹಾಕಿ. ಕೆಲವು ಟೈಮ್ ಏನಾಗುತ್ತೆ ಅಲ್ಲೇ ಜಸ್ಟ್ ಮಿಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ಆ ತರ ಕಟ್ಕೋಬಾರ್ದು. ಓಕೆ, shall we move on to next question?
Yes, sir.
Okay. Consider this statement. It's a very interesting question. See, now you just read the question. Whatever I have given the statement, I have given the two statements. The one statement is an isotropic, not anisotropic. It's isotropy. What is meant by isotropy?
It's elastic.
What?
Identical in all three directions.
Very good. Identical. Isotrope. Okay. So see, an isotropic material is always homogeneous. The next one
No,
is
sir.
an isotropic material is one in which all the properties are not same in all the direction at every
Wrong.
point. So which one is right?
Both are false.
Both are?
False.
Yes, other answers? Second one thing, what if first one show short?
Option is-
That is an isotropic material is always homogeneous. No, it's not a thing. It's not a rule that it's an always homogeneous and all. So the second one is bunny. An isotropic material is one in which all the properties are not same in all the direction. See, all the properties, is it fine? Is not same. Sarina tappa. This thing, this is only one thing. This is very, very important. This is very, very thing. It's a very interesting one. It's right or wrong?
Wrong.
Wrong, sir.
Wrong. So which means to say that all properties are same in all direction?
Anisotropic.
In isotropic?
Anisotropic, sir.
What?
Yes, sir.
Anisotropic.
Yes, see, the thing is, this particular, where the students are committed to mistake, the thing is, this is the thing. If they are giving that an isotropic material is one in which all the properties are same in all the direction at every point, then this option is right. Both A and B are false. Because if you talk about a few physical properties, there are two things. One is physical property, another one is mechanical property. When you are defining isotropy, if you are talking about physical property is same, but mechanical property is having different, that is plasticity. The material, there is no single material like isotropic. There are different materials, right? So all properties are not same. Some physical properties are same, but mechanical properties are different. Clear? If they eliminate this particular thing, read the sentence. An isotropic material is one in which all the properties are same in the
All
direction at
directions.
every point. On that situation, both A and B are false. But he's mentioned that not same. Yes, obviously it's not same. One of the physical property is same, but mechanical in testing. Mechanical properties ಅಂದ್ರೆ ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಲ್ಯಾಬೊರೇಟರಿ ನಲ್ಲಿ ಟೆಸ್ಟ್ ಮಾಡ್ತೀವಲ್ಲಮ್ಮ, ಅವಾಗ ನಿಮ್ಗೆ ಯಾವ್ದೋ ಒಂದು ಐಸೋಟ್ರೋಪಿಕ್ ಮೆಟೀರಿಯಲ್ ಈ ಸೇಮ್ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಂದ್ರೆ ಗೋಲ್ಡ್, ಇನ್ನೊಂದು ಯಾವ್ದೋ ಒಂದು ಸಿಲ್ವರ್, ಯಾವ್ದೋ ಒಂದು ತಗೊಂಡು ನಾನು ಟೆಸ್ಟ್ ಮಾಡ್ಬಿಟ್ರೆ ಆ ಸೇಮ್ ಪ್ರಾಪರ್ಟಿ ಕೊಡುತ್ತಾ ನಿಮ್ಗೆ ಮೆಕ್ಯಾನಿಕಲ್? ಇಲ್ಲ ಅಲ್ಲ. ಸೊ ಬಿ ಕೇರ್ಫುಲ್ ವಿತ್ ದಿಸ್. The word what is used not. So that's why here this is not the case. This is not the case. This is right. Clear? If ಇದನ್ನೇನ ಕೊಡ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಯಾವ್ದನ್ನ ಇದನ್ನ ಕೊಡ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಈ ಯಾವ್ದನ್ನ ಈ ನಾಟ್ ಇದನ್ನ ತೆಗೆದು ಬಿಡ್ತೀನಿ. ಇವಾಗ ಯಾವ ಆಪ್ಷನ್ ಸರಿ? ಇವಾಗ ಯಾವ ಆಪ್ಷನ್ ಸರಿ ಬ್ರೋ?
Option B.
Yes. Now both the statements are false. It's very, very important. Please make a note. Clear? Artha aitandro? Yes.
Yes, sir.
Students. Ellaru
sir.
artha aitara?
Yes, sir.
Okay, okay. See, fast ಆಗ್ತಾ ಇದೆಯಾ, slow ಆಗ್ತಾ ಇದೆಯಾ, correct ಆಗಿ ಹೇಳಬೇಕು. Which one is the following pair is?
Professor, excuse me, so
Yes.
here from Creating Minds.
Yes, sir.
ಅದೇ 7 o'clock ಗೆ ತಾವು ಮುಗಿಸ್ಕೊಡ್ಬೇಕು.
Oh, okay, sir. It's the last question, sir. I will
Okay, sir. Thank you.
Okay. Sorry, sir. Sorry. Okay.
No. Just a reminder.
ನೋಡ್ಲಿಲ್ಲ. Okay, sir. It's okay. Okay.
ಇಲ್ಲ, ನಾನು ಜ್ಞಾಪಿಸ್ತೀನಿ every day 5 minutes.
Okay, sir. Okay, thank you, sir. Yes. ಹೇಳ್ರಪ್ಪ, ಇದರಲ್ಲಿ ಯಾವುದು ಈಗ ನೋಡ್ಕೊಳ್ಳಿ. ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ನ ಗೆಸ್ ಮಾಡ್ಬೇಕು. ಫಸ್ಟ್ ಹೋಗಿ ನಿಮ್ಗೆ ಗೊತ್ತಿರೋದಕ್ಕೆ ಹೋಗಿ. ಐಸೋಟ್ರೋಪಿಕ್ ಮೆಟೀರಿಯಲ್. ನಿಮ್ಗೆ ಲಾಸ್ಟ್ ಒಂದು ಕೇಳಿದೆ, ಏನ್ರಪ್ಪ ಐಸೋಟ್ರೋಪಿ ಅಂದ್ರೆ?
Same physical properties in all the directions.
ಇಟ್ಕೊಳ್ಳಿ, ಫಿಸಿಕಲ್,
Not mechanical.
ಮಂಗ ಆಗ್ಬಿಡ್ತೀರಾ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ. ಓಕೆ, ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಅನ್ನೋದು ನಿಮ್ಗೆ ತಲೆಯಲ್ಲಿ ಇರುತ್ತೆ. ಫಿಸಿಕಲ್ ಮೆಕ್ಯಾನಿಕಲ್ ಅನ್ನೋದು ಇರಲ್ಲ ಅಲ್ಲ. ಸೊ ಫಿಸಿಕಲ್, ಇಟ್ಸ್ ವೆರಿ, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇಟ್ಸ್ ರೈಟ್. ದಿಸ್ ಡೆಫಿನೇಷನ್ ಇಸ್ ರೈಟ್. ನೆಕ್ಸ್ಟ್ ಒನ್, ಆರ್ಥೋಟ್ರೋಪಿ means this is also right. Orthotropic,
Right.
different properties in 3 perpendicular directions, right? What is strain hardening? This is also right. Stiffening effect felt at some stages is called strain. This is a stiffening effect. Strain hardening is nothing but stiffening effect. What? But this one, viscoelastic material. Viscoelastic is not a small plastic zone. It's not a small plastic zone. It's having a wider, that's a permanent plastic. Clear? So this is the thing. It's not matching. It's a false. Remaining all are okay. Clear? Okay. So I hope first class. Yes. Any doubts? Okay. Thank you very much, dear students. I hope I just in first class, whatever we glanced regarding properties and some other things. So in next class, we'll move on to some of the MCQ questions as well as theory part. Very, very important theory part. Don't miss the classes. Okay. So I hope whatever you are having any doubts, you will ask in next class or in free sessions. Okay. Thank you. Thank you very much. Good evening all. Thank you.
Thank you, Professor.
Thank you.
Thank you, sir.